we're not going to graph it. We're going to graph it on the next slide, which is the parent function, because it just kind of makes a little bit more sense. All right, so just a review of your unit circle and talking about tangent with respect to sine and cosine. So remember, tangent of an angle is equal to the sine of the angle over the cosine of the angle. The sine of the angle is the y value when we're on the unit circle. The cosine of the angle is the x value when you're on the unit circle. So if we just looked at one full unit circle right here, the sine of 0 degrees, you go back to your unit circle, you go to 0 degrees, the sine of 0 degrees is 0. Okay, so the sine of 0 degrees is 0. The cosine of 0 degrees, unit circle, I'm not going to go back and forth this whole time. We go to 0 degrees, we look at cosine, which is the x value, which is 1. Tangent is equal to sine over cosine. 0 over 1 is 0. So we can figure out the point. So when we're graphing the tangent in a second, if we of just the parent function, again, we can have all of our transformations. 0 degree, tangent of 0 degrees is 0. So that would be a coordinate point that we use. All right, 45 degrees. So sine of 45 degrees is the square root of 2 over 2. Cosine of 45 degrees is the square root of 2 over 2. Sine over cosine in itself is 1. We never write have a decimal fraction. All right, 90 degrees, that's up at the top. So, up at the top, the cosine is 0, the sine is 1. So, the sine of 90 degrees is 1, the cosine is 0. Sine over cosine, 1 over 0, that is undefined. Again, I'm doing this to show you the pattern. There's going to be a pattern, just like there was with sine, cosine, secant, cosecant. Inverse sine, inverse cosine, tangent and cotangent are going to have a pattern also. 135 degrees. 135 degrees right here. Okay, we have the same values, but the cosine is negative because we're in quadrant 2. So the sine of 135 degrees is root 2 over 2. The cosine is negative root 2 over 2. So that gives us a negative 1. 180 degrees over on the left. The sine of 180 degrees is 0. The cosine is 1. 0 over 1 is 0. 225 degrees, that's down in quadrant 3. Negative root 2 over 2. Negative root 2 over 2. Negative over negative is a positive. 270, that's down at the bottom. 270 at the bottom, the sine is negative 1, the cosine is 0, negative 1 over 0 is undefined. Hopefully you're seeing this pattern that's being created over here for the tangent. 315, quadrant 4, sine is negative, cosine is positive, that gives us a negative 1. And then at 360, we're back at the start. We've made one full rotation. The y value is 0, the x value is 1, 0 divided by 1 is 0. So, with sine and cosine, we had this pattern that happened. A full rotation was a pattern, and then if we did another full rotation, there was that pattern. But this pattern repeated more often. We went 0, 1, undefined, negative 1, 0, 1, undefined, negative 1, 0, 1. So there's 2 cycles in one rotation. Okay, so there's tangent and cotangent graph's going to be a little bit different. So our period, if we look on this page right here, okay, is not 360 or 2 pi. It's going to be 180 degrees over b or pi over b. Sine and cosine, one cycle happened in one rotation. Tangent and cotangent, 2 cycles happened in one rotation. So therefore, one cycle happened in a half a rotation, so that's why it's 180 over b or pi over b. And that's going to be for tangent and cotangent. Now, I don't want you to get your calculator out, but I'm just going to show you what a tangent graph looks like. We go to y equals, and we type in tangent of x, just so we kind of have an idea of what we're about to do. That is a tangent graph. It repeats over and over and over again. We have all of these exact same shapes that are just going to continue to repeat. Now the calculator doesn't show asymptotes, but we have asymptotes. How do we know we have asymptotes? Because we just had all these undefined. But we want to graph one cycle. So when we look at this, notice that this point right here, we want to graph this middle section. That's going to be our one cycle of the parent function that we graph. So the middle right here is at 0, 0, or 0 degree 0. So we need to go negative and positive to get that full cycle. We don't want to graph like half of one and then half of another. We want to graph that one full cycle all together. So that's why we have this sheet right here that says these are going to be the parent function points that we use. So we start in the middle, and we're going to go to the left and the right. And because our period is 180 degrees, if we want to start at 0, we need to go 90 to the left, to the negative 90, 90 to the right, to positive 90. So we already filled that in. We already got 0. What did we get? 45 degrees, 1, and undefined. If we go back the other way, tangent of negative 45 is in quadrant 4, so that would be negative 1. Tangent of negative 90 is down at the bottom, so the 0's in the denominator, so undefined. So those are the points we want to plot on our parent function point. So we have negative 90 degrees, negative 45 degrees, 0 degrees, 45 degrees, and 90 degrees. Our y-axis is still at 0 degrees or 0 radians. It's going to be at 0 wherever that 0 is. We have undefined at negative 90 and positive 90, and that again is a pattern. It will always happen for your tangent, and when we do cotangent in the middle, your asymptotes are always going to be on the ends because we want to graph one full cycle all at a time. And now we can plot those points. I, with tangent and cotangent, always plot the middle point first. So I'm going to start here, and then I always know that tangent goes right and up, so 45 degrees, it's at 1. And at negative 45 degrees, we're at negative 1. And then we're going to connect those. So we approach the asymptote. This isn't always the easiest to graph, but we approach those asymptotes. We don't go to the asymptotes, okay? Drawing something like this would not be acceptable, okay? That's not a thing, okay? Doesn't look anything like that pink line I drew. So it needs to curve through those points right there. We don't want a lot of curves. You can't curve here and then here like that. It doesn't look like that. It's got to just have a nice bend to it through those points. And I will tell you one thing that makes it a little bit easier. The closer you keep your high and your low values, the easier it is to draw that. When these values start getting really far apart, then it's really hard to keep that curve to go through them. So again, keeping those values close but labeled correctly are going to be what is important. So this hint down here, it says graph the center first. So just like with our everything else, we have y equals a. Now we're going to have tangent and cotangent. B, theta or x, whatever it is, minus c plus d. Up until this point, our c value is where we started. We always started on the left. We started with our c value there. Okay, this is exactly the same. We had this word sine in here, cosine in here, secant, cosecant. Now we're just going to put tangent and cotangent. All of these other letters stay the same. So with tangent, our c value, we didn't go anywhere. Notice was in the middle. And that is only with tangent. I'm going to say it over and over and over again because I do not want any of you to miss it. Because if you miss where to start on your tangent, that whole x-axis is wrong. You can still get the shape right. You can still get your y-axis right. But that entire x-axis is going to be all wrong because none of your points are going to match up. So when you're graphing a tangent, whatever your c value is, that goes in the middle. And then we go, the period is 180. So we went half the period one way to negative 90. Half the period the other way to 90. So it's still, from start to finish of the graph, is 180 degrees. It's just when we plot the middle first, we have to go half the period, 2 halves of a degree, make one whole period. So that's what's a little bit tricky and different about tangent. Everything else, cotangent in a minute, is going to start on the left. Everything C value always starts on the left, except for tangent. Tangent is one that does not. All right, there is a mistake on this. So down there at 315, I think this is filled in for you on your notes. At 315, I think is the one where it says cosine. Cosine should be positive right there. I think that's a negative sign, so just fix that. Easy little fix right there. So we just did all the sines and cosines. We don't have to refill it in, so they're filled in for you. But if we're thinking about cotangent, cotangent of an angle is equal to the cosine of an angle over the sine of an angle, which is the x value over the y value. So now we're looking at cosine over sine. So 1 over 0 is undefined. 0 in the denominator is undefined. 0 in the numerator is 0. Denominator undefined. Same thing over itself is 1. 0 over 1 is just 0. Negative over positive, negative 1. Negative 1 over 0, we're back to undefined. So now we're going to start that pattern again. So we're only at 180 degrees, and we're already starting that pattern over. Negative over negative is positive. 0 over negative 1, 0. Positive, again, the correction over negative, negative. 1 over 0 is undefined. So again, yes. Never. Nope. Never. Okay, you won't have a table. This table really isn't something that you would do every time. This table is kind of just a little review of, hey, remember about the unit circle? We don't want you to forget it. We're going to keep like ingraining that in your brain. But no, we would not give you a table. We would not give you any of those values. You have to know what they are. Okay? We would say, graph this function. And if you want to make a table, you can, but you don't have to. Okay? It is up to you. So, just like with tangent, okay, again, I'm not going to graph all of those points, but I am on the next page. We are going to graph one cycle. Now, I'm going to go to my calculator again, and I'm going to graph a cotangent just so you can see what it looks like. Don't get your calculator out, just let me show you. There's not a cotangent button. Cotangent is the reciprocal of tangent, so I would do 1 divided by tangent of x and graph it, and that's what it looks like. So sort of similar. It looks like it's just going the other way. Tangent went up and to the right, up and to the right. This one's going down and to the right, down and to the right. So it's kind of like a flip-flop of the tangent. It is not considered a negative tangent. The graph of it looks like that, but notice cotangent does not go from 0, 0, and tangent did. If I were to show them on top of each other, here is tangent of x. Notice it's not just a reflection. Okay, if we just take one piece and take all the x and y axes out, it is a reflection. Like a negative cotangent shape looks like a positive tangent. And a negative shape is going to look like a cotangent. But notice it does not go through the same places right there. So, with cotangent, we're back to starting at the C value on the far left, because our first value right there is 0. On our parent function, our C value is 0, so that is going to give us that one full section right there. So on here, we are going to start at 0 degrees, and just like the table told us, the cotangent of 0 degrees is going to be undefined, because that is 1 over 0. The cotangent of 45 degrees is 1. 90 degrees, 0. 130, and I'm just getting this off that table that we just filled in. And then at 180, we're undefined. So, cotangent, y equals cotangent theta. Y equals A, cotangent B, theta minus C plus D. There's no C, there's no D. A is 1, B is 1. So it's just our regular parent function. 0 degrees, 45 degrees. See? And again, why? Let's see, why are those the values versus 0 to 360? Because we want to graph one cycle, and cotangent and tangent have 2 cycles in one rotation. So we've got to split that in half, and our period for tangent and cotangent right here is 180 degrees over b, or pi over b. So we're in degrees, so 180 divided by 1 is 180. So from start to finish is 180 degrees, halfway is 90, halfway 45, halfway 135. So we have our y-axis right here at 0, but we also have an asymptote, and we have an asymptote here. So again, when I plot these, I usually start with my middle point. So 90 degrees 0, and then at 45 degrees we're at 1, or I think of it, I go left, so you go label my 1 and negative 1, left and up, right and down. That's that cotangent. Or I can plug that value in and see what it equals. And then we can approach that asymptote. Make sure you go all the way to the asymptote, and there is your parent function of the cotangent graph. Cotangent, our C value, there was nothing there. Nothing is 0 degrees, it's 0. Tangent starts our C value in the middle. Tangent's the only one that starts in the middle. Everything else, sine, cosine, secant, cosecant, and cotangent. All 5 of those start on the left. Your C value is on the left. Tangent, your C value is in the middle. All right, there is one thing on your homework. We don't have this on our notes, but on your homework it talks about the center. Label the center point. Well, that is the center point. So that center point would be x, which is 90 degrees, comma y, which is 0. So if it asks for the center, that's all it wants to do. Okay? That is your center. All right, so one full cycle, list 2 values where it's discontinuous. So tangent. A, we have an A value. This is A tan B, theta minus B plus B. Now the 3 is in the parentheses versus out of the parentheses. Because there is no C value, it doesn't matter if there's even parentheses there. There could be parentheses, not parentheses, around the C, around the theta, around both of them, just around the theta. None of those matter. If there was a C value in there, we'd have to factor that 3 out because that would affect our shift. Okay, but there is no C value, so that's why it doesn't matter that that 3 is inside the parentheses or not. That's going to affect our period. 3 is B. B does not equal period. B is the frequency. All right, so C is 0, and we are in radians because it tells us, because there's no C value shift, so we have to be told. So it's tangent, so I'm going to put my 0 in the middle. Tangent starts in the middle. Now, my period is going to be equal to pi over b. So period is pi over 3. Period is still start to finish. Even though I put my C value in the middle, that doesn't change the fact that start to finish of my graph is the period. So I can't go from 0 to pi over 3 because now I've run out of space. So I have to go half the period one way and half the period the other. It's really nice when that's 0, because if I go half the period one way, then over here is the negative. And halfway between 0 and a third, pi over 6, and so negative pi over 6. So with zeros in the middle, it's easy. So, I did not even do what I just said. Ignore all that. Let's start over. Pi over 6 is halfway. Negative pi over 6. Now that is equal to pi over 3. Okay? When that middle number is 0, you can go half one way and half the other, and it's easy. One's positive, one's negative. So 1 pi over 6 and 1 pi over 6 is 2 pi over 6, which is 1/3 pi. That's the whole distance. And then half of 1 over 6 is 1 over 12, so pi over 12, and negative pi over 12. and our y-axis is in the middle. We have our asymptotes out here on the ends. Our vertical stretch. A was our vertical stretch. Up to, down to. Again, I usually always plot my middle point first, and then I know it's tangent. Tangent goes right and up, left and down, and I can go through those points. And notice how my 2's are kind of close, so the closer you make these, again, they need to be labeled correctly, but I've just found the closer you kind of put those together, the easier it is to draw that. It's not wrong if you put them far apart, it's just harder to make that graph look correct. Now, it says 2 values. This is discontinuous forever and ever and ever. It asks for 2 values. There's 2 on the graph, so theta equals negative pi over 6 and positive pi over 6. You could say plus or minus pi over 6. You don't have to put the plus in front of the pi over 6. Plus or minus pi over 6 would be okay if you want to write it like that. And discontinuities will happen every pi over 3. From negative pi over 6 to pi over 6 is a difference of pi over 3. So if you add another pi over 3 to pi over 6, you have another discontinuity. And they'll just keep going on and on like that forever. All right, cotangent. So here's our D value, our A. A is negative, so we're going to have a reflection. B and C. It did not tell us degrees or radians. This tells you, you have to know that that means degrees. You see a degree symbol, degrees. You don't see a degree symbol and it didn't tell you, that's how you know that it's in radians. Now remember, this is theta minus C. So C is negative 20 degrees. B is negative 3, or we're going to move down 3 if you think of it that way. You don't have to write them down. I just am, so you can see what we're doing. Cotangent, back to normal. We start on the left, so negative 20 over here on the left. And then we've got to go the period. So the period here is going to be 180 degrees over B, which is 2. So our period is 90 degrees. Negative 20, and we add 90, takes us to 70. Add and divide by 2, so 50 divided by 2, 25 degrees. 5 divided by 2, or 2.5, I don't care which one you do. 95 divided by 2. Don't divide 95 by 2 wrong and then get that point wrong. Leave it 95 over 2. You want to figure out what 95 over 2, what, 47.5, I think? 47.5? Fine. But if you put 45.5 or 46.5 and you do it wrong, now that is wrong. Okay, you do not have to simplify. 50 over 2, you need to simplify. 50 and 2 are even numbers. 2 does not go into 95. I don't care if you simplify it or not. The y-axis needs to be at 0. The y-axis is always a 0 or 0 degrees. We know our asymptotes. We could go ahead and draw those. Are going to be on the ends. We could even list our discontinuity. Theta equals negative 20 degrees and 70 degrees. We know that for sure, even if we forget how to graph it. Get that part right. And then we move down 3. So that's your new middle. Again, I like to draw a little dashed line, not necessary. And 5. So from negative 3, we're going to go up to 2 and down to negative 8. Be sure those are all labeled right there. So the y-axis is in the correct place. The 2, the negative 3, and the negative 8 are labeled, along with your 5 values on the x-axis. All right, now we're ready to graph. Again, I personally always plot my middle first. And I know cotangent goes left and up, but it was negative, so I reflect that over. Cotangent goes right and down, but I reflect that over because it was a negative 5. So that's a reflection, which takes on the shape of a tangent. A negative tangent takes on the shape of a positive tangent. It is not just a reflection because the points aren't the same, but as far as the shape goes, that is what it looks like. If you forget what your shape looks like, you can plug those numbers into the equation given, and you will always get a value that is on the unit circle that you're able to evaluate, always. If it's not, then your x-axis is not correct. Either you added or multiplied wrong, or you did some kind of add and divide by 2 wrong on your axis, or you started at the wrong place. Those are the only options. All right, the last one, we're back to tangent. So again, remember your C starts in that this is theta minus C. So C is -1. D is -2. There's no degree symbol. So the period is pi over 6. Pi times 6 over pi. Our period is just 6. Pi over pi is 1. Remember, your C and your period will always be like terms. You will never have anything that's not like terms. If your C value has a degree symbol, your period is going to be in degrees. If your C value is just a number, your period is going to be a number. If your C value has a pi, then your period will have a pi. They have to be like terms. We're not going to give you anything where they're not. All right, important, tangent. Tangent starts, our C value is in the middle, so -1 is going to be in the middle, not on the left. Everything else is on the left. Sine, cosine, secant, cosecant, cotangent on the left. Tangent, C is in the middle. Our period was 6. Do what? No. So here was our cotangent. C value is -20. We started on the left. Here is our parent function. C was 0. We started on the left. Here's the little note that says cotangent. We graph from left to right. Tangent is the only one where we start in the center. Okay, tangent's the only one that starts in the center. All right, so -1 is in the middle. Our period is 6, so we need to go +3 and -3. Then we add and divide by 2, 1/2. I like fractions. If you like decimals, fine. -5 over 2. Our y-axis goes at 0, so between the negative and the positive. Our middle axis went down 2, so -2. There's your new middle. Go ahead and draw my asymptotes. Doesn't matter if you do that first. You have a cotangent, go draw them right away. And from -2, we went up 4 to 2 and down 4 to -6. I like to start in the middle. Tangent goes right and up. It was positive, so that stays. Left and down. And there is your tangent graph with discontinuities at theta equals -4 and 2. And again, on your homework, it asks for the center. So all that is what's the middle, what's the center point. The center point on here is -1, -2. That's what it means when it asks for the center on your homework.